A mass m is moving with a constant velocity along a line parallel to the x-axis away from the origin. Its angular momentum with respect to origin is 0, remains constant, goes on increasing, goes on decreasing. Okay, look, let's draw the figure. Let us first draw the figure. A mass m is moving with a constant velocity along a line parallel to x-axis. Okay, let this be the trajectory. Let this be the trajectory. Okay, suppose this is v bar. Okay, it is moving with a constant velocity along a line parallel to x-axis. So the velocity has to be v I cap. Okay, the velocity has to be v I cap. Now pay attention. Let's say its position at any given instant is given by r bar. Okay, it's given by r bar. Okay, now that r bar is x I cap plus y j cap. Correct, that r bar is x I cap plus y j cap, but because this line is parallel to x-axis, its equation has to be y equal to constant. Okay, so when it comes to r bar, I can say that it is x I cap plus b j cap. So what will be v bar? Dr bar by dt. That is v I cap, right? Because this is 0 j cap, and we know that. Okay, we know that. Now let's calculate angular momentum r bar cross p bar, or m times r bar cross v bar. R bar xb0, v bar v0 0, I into 0 minus j into 0, okay, I into 0 minus j into 0, and k into what? K into negative bv remains constant. Okay, remains constant. Okay, now let's try to argue like this, if you see, if you find it convincing. Okay, this is fine, this is absolutely fine, but what made him think that it goes on increasing is perhaps the length of the radius vector which went on increasing. Is that right? Yes. Okay, so let's just see if we can come up with the conclusion by qualitative arguments, or not so precise arguments, but that's fine. Okay, this is r bar and that's v bar. Okay, now r bar cross v bar, we know it is going to be a vector along x-axis. Let us just focus on its magnitude. Okay, let us just focus on its magnitude. It will be mvr sin phi. Or mvr sin theta. Okay, mvr sin theta. Now look here. Mass is constant, v is constant. And what is r sin theta? Is it not the y coordinate of the point? Right? Look here. Suppose this is the vector r bar, the red vector. Okay? Now the angle that it makes with x-axis is essentially the angle that it makes with velocity v bar, because velocity v bar is also horizontal. Is that clear? Now if the distance is r at any given instant, what can you say about the segment of the green length of the green segment length of the green segment? It's r sin theta, but that's constant. So even without using the cross product, you can not exactly using the cross product, you have to use cross product, but not necessarily using the determinant working rule, we can still arrive at the same result, that it is indeed equal to MVP. First one is always going to work. Okay, I always prefer the first one, I, J, K, X, B0, B0, 0, because that gives us both magnitude and direction. And see, now this actually gives us a wider view. Let's say if we have projectile motion, then you know that V is V cos theta, and well, the Y component is V sin theta minus GT and 0. And if you integrate them, then you can get these equations, these things. also. Okay, and well, that basically works all the time.